Hello students, I am Azizi, Professor Electronics, and we are learning the course of Assembly Language Programming using MCS 51 family. In our previous session, we have learned that how to display a text message on first row of the LCD. In this session, we will learn that how to display the embedded data on the LCD. First, we will go through our previously written program, and then we will write a program to display a 3-digit counter value on LCD display. So let's start today's session. And here we can find the result of our previously written program, that is my first LCD project. And now we'll write a program to display a 3-digit counter value on the second row of this LCD. So let's see how we can write our new program. And here we can find our previously written program, that is LCD message display. And here we have the LCD initialization commands. And here we have ports assignments, we have bits assignments, we have directives, initialization routine. And here we have written a 20 millisecond delay for LCD initialization, and here we have written the LCD initialization routine, and here we have the main routine, and we are calling two subroutines, that is go position and print message. And here in go position we have selected the address of the first row, that is ATH, and in print message routine we have written a program to display 20 characters. That is my first LCD project on the LCD display, and here we have written delays of 2 milliseconds and 50 microseconds. And now I'll modify this program to display the embedded data on the LCD. That is a 3-digit counter on the second row of the LCD. And to write our new program, first we'll save this file with a new name. So we'll go to the file, save as, and here we will save this file with a new name, that is LCD counter project 1. So here we have written the name of a new ASM file, that is LCD counter project 1.a51. Okay, save. And now we'll close this project. And now we'll open a new project, new Macrovision project, and here we will assign the name to our project, that is LCD counter project 1. Okay, save. And we'll select the microcontroller, that is 89C51. Okay. No. Target 1, right click, option for target 1. And here we'll select the crystal oscillator frequency, that is 12 megahertz, and we'll go to the output and we will select this checkbox, that is create hex file. Okay. And now we'll add the ASM file to our project. Source group 1, right click, add existing file to the source group 1, and here we can find the ASM file, that is LCD counter project 1, add. And here we can find our previously written program, that is LCD message display. Now we'll change the name of our project, that is counter project. So here we will change the comments for our new file. So here we will write, that is counter project, and here we have changed the comments, that is counter project 1. And here we can find the initialization commands for the LCD. Here we can find we have written the LCD initialization routine, and we have moved all initialization commands to the LCD port one by one. We can also write this LCD initialization routine in another way, using the instruction, that is move at the rate. So let's see what is the instruction, that is move at the rate. And here in MCS 51 of course we can find the instructions, that is move x at the rate R0 and move x at the rate R1. And both the instructions, that is move x at the rate R0 and move x at the rate R1, are used to move the data externally when we will use the microcontroller in microprocessor mode. But here we can find two other instructions, that is move at the rate R0 and move at the rate R1. These instructions are used to move the data from the internal RAM to the accumulator, but only two registers from the register bank, that is R0 and R1, can only be used for this instruction, that is move accumulator at the rate R0 and move accumulator at the rate R1. And we cannot use other memory locations from the RAM for this instruction, that is move accumulator at the rate R0 and move accumulator at the rate R1. And here we can find the difference between move and move at the rate instructions. And here we can see we can move any memory location to the accumulator, that is move accumulator R0 to move accumulator R7. We can move the constants to the accumulator by using the instruction, that is move #00h or any number other than 0. We can move all the memory locations to the accumulator by using the instruction, that is move accumulator. And here we can find a command for LCD initialization, that is clear display. And here we have assigned the value, that is 01 to the clear display by using the equate, which is the directive for the compiler. And here we have assigned the variable to the first memory location, that is data reg. And here we can find an instruction, that is move data reg # clear disk It means that we have moved the value that is 0, 1 to the data reg, and here we have moved the constant value that is 30h to the R0, and on the next line we have moved the contents of the R0 to the accumulator. After executing this instruction, that is move accumulator R0, the contents of the accumulator will be 30h. But here we can find another example, that is here we have defined a constant that is clear disk equals to 1, and we have assigned the name to the first location of the RAM that is 30h, that is data reg, and here we have moved the value that is clear disk as constant to the data reg, and here we have moved the value that is 30h to the R0, and if we'll use the instruction that is move accumulator at the rate R0, the contents of the accumulator will be 0, 1. Because using this instruction that is move accumulator at the rate R0, the compiler will consider the number which is in R0 as the address and move the content of that address into the accumulator. And here we can see we have assigned the name to 30h, that is data reg, and we have moved the constant that is clear disk to the data reg. So in this case the value of R0, which is 30h, will be considered as address, and the contents from that address will be moved to the accumulator. So after executing this instruction that is move accumulator at the rate R0, the value of the accumulator will be 0, 1h. As we have seen from the opcode charts from the MCS 51 family, only two registers can be used for this instruction, that is move accumulator at the rate R0 and move accumulator at the rate R1. But we can find another instruction from the opcode chart of the MCS 51 family, that is move code. In this case we can write that move code accumulator at the rate accumulator plus dptr. dptr is the data pointer. Say for example we have developed a lookup table, that is lookup table colon define byte, and here we have defined 3 bytes, that is 00h, 01h, 02h. Now the instruction that is move code accumulator at the rate accumulator plus dptr will move the value from this lookup table to the accumulator, and here we can check how to perform this operation. And here on this line we have initialized the value of R3 to 00h by using the instruction that is move R3 #00h. Now we have moved the address of the lookup table to the data pointer. Say for example address of the lookup table is 01FFH within a memory range of 64 kilobyte. So this address that is 01FFH will be loaded to the data pointer, and here in the routine that is back 0, we have moved the value of R3 to the accumulator by using the instruction that is move accumulator R3. It means we have moved the value that is 00 to the accumulator, and here we can find the instruction that is move code accumulator at the accumulator plus dptr, and here on this line the contents of the accumulator will be considered as address, and the address of the data pointer will be added to the accumulator. So the address will be 01FFH, and the value of the first member of the lookup table will be moved to the accumulator, and here we can find the value of the first member of the lookup table is 00h. So the number 00h will be moved to the accumulator, and here on this line we have moved the value of the accumulator to the port 0, and here on this line we are comparing the value of R3 with 2 because we want to send 3 data, that is 00, 01 and 02 to the port 0 by using the instruction that is compare jump not equal R3 comma #2 increment R3. If the value of the R3 will not be equals to 2, then a program will jump to the increment R3, and here it will increment the value of R3 and program will jump back to the back 0 subroutine. Now the value of the R3 register is 1, and we have moved the value that is 1 to the accumulator, and by using the instruction that is move code accumulator at the rate accumulator plus dptr, now the address of the dptr will be incremented by 1. So the value of the second member from the lookup table, that is 01, will be moved to the accumulator, and here we'll move the value of accumulator to the port 0, and program will go to the next line to execute the instruction that is compare jump not equal R3 #02 increment R3. But if the value of the register R3 will be equals to 2, then a program will come to the next line and will get written from the subroutine. So we'll use the same technique in a program to initialize the LCD, and now we will write the variable assignments. So here we will write, and here we will write that is cd underscore reg EQU 30H, which is the first memory location of the general purpose RAM, and we'll write that is CH, that is cursor home reg EQU 31H, that is EM underscore reg, that is entry mode set reg EQU 32H, DOF, that is display on off reg EQU 33H, CDS underscore REG, that is cursor display shift register, EQU 34H, and FSREG, that is function set, (35H). And now we will move these binary values, that is clear disk, cursor home, entry mode set, display on off control, cursor display shift, and function set to these registers, that is CDREG, CHREG, EMREG, DOFREG, CDSREG, and FSREG. And here in initialization routine we will write that is MOV CDREG, comma hash clear disk, and we will write that is MOV CHREG, comma hash cursor home, and here we have moved all 6 LCD initialization commands to the variables, that is CDREG, CHREG, EMREG, DOFREG, CDSREG, and FSREG. Now we'll use these memory locations in our LCD initialization routine. As we have seen that we can use only 2 registers from the register bank, that is register R0 and R1 for the instruction that is move at the rate accumulator R0 and move accumulator at the rate R1. So first we'll replace these registers, that is R0 and R1, from the 2 millisecond delay routine. So here we'll write that is R4 and R5, and here we'll use that is R5 and R4. And now we can use the register that is R0 in our LCD initialization routine. And here in LCD initialization routine we will write that is move R0, comma hash 30H, and here we can see we have assigned the name, that is CDREG, to the memory location 30H. So here we have used the location, that is 30H. And now we'll use the instruction that is move accumulator at the rate R0, move accumulator, comma at the rate R0. Now the contents of the register, that is R0, will be moved to the accumulator, and the value of the 30H location is clear disk, which is equals to 01. It means that the value, that is 01, will be moved to the accumulator. And here on next line we'll move the accumulator to the LCD port. So here we will replace this constant with the accumulator. So we will write that is A, and here we will call the MS delay, clear enable, call MS delay once again, and set bit enable. And now we will remove all these instructions from the LCD initialization routine. And here we will write that is compare jump not equal R0, comma hash 35H. That is the address of the 6th LCD initialization command, that is function set. So here we have compared the value of R0 with 35H. If the value of the R0 will not be equal to 35H, then a program will jump to a subroutine and will increment the value of the R0. So here we'll write that is comma INC underscore R0. But if the value of the R0 will be equal to 35, then a program will jump to the main. So here we will write that is jump main, and here we will write the subroutine, that is increment R0 using colon, and here we will write that is increment R0, and after incrementing the value of R0, our program will jump back to move the next initialization command to the LCD port. So here we will write that is jump NXT underscore INI, and here we will write that is NXT underscore INI using colon, So here we have modified our LCD initialization routine by using the instruction that is move accumulator @R0. Now here in message 1 we'll change the text that is counter value. So here we will write that is counter value. And we will adjust the length of the message for 20 characters. So here we will add some blank spaces before and after this text. So here we have adjusted the length of the message for 20 characters. And now we'll compile our program and we'll check the result of our program on Proteus software. 0 error, 0 warnings. And now we'll load the new hex file to the microcontroller. And here we can find the LCD counter project 1 hex file. Okay, and now we will run the simulation. And here we can find we have written the text that is counter value on the first row of the LCD. And now on second row we'll display a 3-digit counter. To display a 3-digit counter on LCD display, here we will define 3 variables, that is unit digit, 10 digit and 100 digit. So we will write that is UNI underscore DIG EQU 36H 10 digit EQU 37H and 100 digit EQU 38H. And in initialization routine we'll initialize these variables. So here we will write that is move unit digit comma hash 00H move 10 digit comma hash 00H and move HUNDIG 100 digit comma hash 00H. And now we'll print the value of these 3 digits on the LCD display. And here we can find the character addressing for the 20x4 LCD. And here we can find all the addresses for rows and columns. And in our program we'll show the unit digit on CA, 10 digit on C9 and 100 digit on C8. And here in main routine we will add another subroutine that is print counter. So we will write that is call PRNT underscore CNTR is the name of our new subroutine. And here after print message subroutine we will write the new subroutine that is print counter. So we will write that is, and here we will write print counter using colon. And here in print counter routine we will move the cursor to the position that is CA where we want to print the unit digit, and we will copy these lines from the go position subroutine, Control C, and we will paste these lines here, Control V, and we'll change the address that is CA, and we'll remove this instruction from here. And now we'll move the value of the unit digit to the accumulator. So we'll write that is move accumulator comma unit digit. And now to print the value of the unit digit to the LCD, first we'll convert the value of the unit digit to the ASCII character. And here we can find that how to convert the number that is from 0 to 9 to its equivalent ASCII hex value. Say for example, if we have the number 0, first we'll perform the AND operation with 0FH to mask the higher nibble, and we can find the result here on next line. The result will be 0 because the lower nibble of the number is 0. So we will get the result that is 0. Now we'll perform the OR operation with the result using 30H, and here we have performed the OR operation with 30H, and here we can find the result if we'll perform the OR operation with 30H. So we'll have the result that is 30H, that is the equivalent ASCII hex value for 0 is 30H. Similarly, if we'll have the number that is 09, first we'll perform the AND operation to mask the higher nibble, then we'll perform the OR operation with 30H to make the higher nibble 3. So we'll have the result that is 39, which is the equivalent ASCII hex value for the 9. So we'll use this procedure to convert the number that is from 0 to 9 to convert the number to its equivalent ASCII hex value. And here we'll write that is ANL, that is AND logic, accumulator, comma hash 0FH, and next we'll perform the OR operation, and we will write that is ORL accumulator comma hash 30H, and now we'll move the value of the accumulator to the LCD port. Before moving the value of the accumulator to the LCD port, first we'll set the status of the RS bit. So here we will write that is set bit RS, and now we'll move the value of the accumulator to the LCD port. So we'll write that is MOV LCD PRT comma A, and now we will call the millisecond delay. And now we'll clear the status of the enable bit. Now we'll call the millisecond delay once again. And we'll set the status of the enable bit as 1. So we'll write that is set bit EN, and we will call the millisecond delay once again. Here we have written the value of the unit digit to the address, that is CA, and now we will write the value of the 10 digit to the C9 address. So we'll repeat this procedure for 2 more times to print 10 digit and 100 digit on LCD display. So we'll copy these lines from here, Control C. And we'll change the address to C9, and we'll change the digit to 10 digit. And here we will change the address to C8, and we will change the digit to 100 digit. After printing all these 3 digits, our program will get returned from the subroutine. So here we will write that is return. Here we have completed our print counter subroutine. Now we will compile the program and we'll observe the result on Proteus. Here we can find 3 errors, undefined symbols, and here on line number 119, here we can find an error, and here we can find a hex value. So we'll place a 0 before the C, and also here. And now we'll compile our program once again. 0 error, 0 warnings. And now we will run the simulation. Here we can check the result of our program is not as per our expectation. So let's see what is the error in our program. And here we can find we have set the value of the RS, but we have not cleared the value of the RS after printing the character. So here we will write that is clear, that is RS. And here we will write that is clear RS, and here we will also write that is clear RS. And now we'll compile our program once again, and now we'll run the simulation once again. And here we can find the result of our program as per our expectation, that is a unit digit, 10 digit and 100 digit. In this session we have learned that how to print the embedded data on LCD display. In next session we will learn that how to increment the counter and how to display the value of the counter on LCD display. Thanks for watching this semi-language programming course. We hope that you find this course very helpful to learn semi-language programming. If you feel that this course contributes and enhances your embedded system design knowledge, then go ahead and hit like, share and subscribe buttons, and do not forget to press bell icon to stay updated with every new upcoming video from Electroeducators as soon as it goes up. Electroeducators also offers technical consultancy in following fields. For assistance regarding technical problems, projects and any consultancy, feel free to reach out at our email address electroeducators@gmail.com. Okay, see you in next lecture.